In this example, we're going to use logarithmic differentiation to go ahead and take a look at this equation and find its derivative, or to find dy dx, or y prime. Alright, so if you'd like to pause the video and give this a try first, go ahead and do so, and come on back and we'll work it together. Alright, so looking at the right side of this equation, we have the natural log of x raised to the power of the natural log of x. Well, x is included both in our base and our exponent, and sometimes this can be a bit of a challenge to take the derivative of something like that. But using logarithmic differentiation, we can clean it up and make it not quite so bad. So the beauty of this is that we can use the properties of logs to rewrite this right side. Okay, so let's go ahead and take the natural log of both sides of this equation. So I'll have the natural log of y, and then the natural log of, well, the natural log of x raised to the power of the natural log of x. Okay, well, we did this so we can take this exponent here and rewrite it, bring it out front as a coefficient. So really what I have is the natural log of y equals the natural log of x, which was this exponent, times the natural log of the natural log of x. Okay, so ln's abounding here. So at this point, let's go ahead and take the derivative of both sides. And it looks like on the right side, we'll have a nice product rule where we have the first function here and the second function here. And you'll notice up here I have written this derivative rule. This is the derivative of the natural log of some function u is going to be u prime over u. And you can find this and many other derivative rules typically in the front cover of your calculus book. Okay, so let's go ahead and do this. So the natural log of y, well, that's going to end up being y prime over y for that derivative. And then let's do the product rule here. So the product rule is the derivative of the first, which is 1 over x, times the second, plus the first times the derivative of the second. So we're taking the derivative here of the natural log of something. So it'll be u prime over u. So the derivative of this, which is 1 over x, over that, which is the natural log of x. Okay, something immediately that's nice, we can cancel those ln of x's right there. And you'll notice also each of these terms has a 1 over x. So we could try factoring that out. It might look something like 1 over x times the natural log of the natural log of x plus 1. Okay? But remember, we're trying to solve for this y prime right here, which means we need to get rid of this division by y. So let's go ahead and multiply both sides of that equation by y. And so on the left side, they'll cancel. So I have y prime equals. But remember, what was this value for y from our original equation? Well, it was the natural log of x to the power of the natural log of x. So I'm going to go ahead and exchange that and say it's the natural log of x to the power of the natural log of x. And so let's see now what we have for this entire thing. I'm going to go ahead and bring this product up front and join this 1 over x. So it looks like the natural log of x to the power of the natural log of x. That's over this x. And then that's going to be multiplied by the natural log of the natural log of x plus 1. So here we have our derivative. We've solved for y prime, or dy dx, and we have this expression. And again, we use logarithmic differentiation to get there. So this is what we started with. We use a nice derivative rule, and here is where we end up. So there's that example.